right, we're now in our third section of chapter 11, 11.3. We're going to talk today about combinations, where remember in our last section we talked about permutations, where order does matter, and when you rearrange it, it gives you a different outcome. Today, though, we're going to talk about combinations, and combinations is when order does not matter. For example, if I just listed a couple of random people, I have Lady Gaga, Channing Tatum, Justin Bieber, Adam Levine, Barack Obama, Kim Kardashian, Donald Trump, LeBron James, and Peyton Manning. So out of these 9 people, if I said that you could choose to go out to dinner with 2 of them, how many different ways can you pick 2 people to go out to dinner with from this list of 9? Well, it doesn't matter if you picked Lady Gaga and Channing Tatum, and whether they sat to the left of you or the right of you, it would still be those same 2 people, right? Whether it was Lady Gaga and Channing Tatum or Channing Tatum and Lady Gaga. And so picking those 2 people, order doesn't matter because it's the same 2 people no matter what. And so we have less options total because picking those 2 people is the same no matter which order they sit at the table, right? Okay, so that's kind of an example of a combination, where a combination is where you pick a selected group from selected items from a group, that no item is used more than once, and that order makes no difference. So changing the order in which you pick them or which you arrange them doesn't add or change the outcome. Okay, so that's the first huge difference between a combination and permutation, and that's one of the hardest parts of all of these chapters, is that on your test it's not going to tell you if it's a combination problem or a permutation problem. You've got to be able to read through the problem and first decide is that a combination or a permutation, and then solve the problem from there. So let's work on that first. So remember, a permutation is a problem where order does matter, and a combination is a problem where order does not matter. So let's look at a few examples and let's figure out if we think it's a combination or a permutation. Example number 1A says that 6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes gets to become the president, the second highest vote getter gets to become vice president, and the student who gets the third largest number of votes is the treasurer. How many different outcomes are possible? So we have 6 students total, and we have a president, a vice president, and a treasurer. Now, does order matter? Well, the person with the highest number of votes gets to be the president, second is vice president, and third is treasurer. So order does matter in this particular example because one person is going to be the president versus vice president versus the treasurer, and it'll make a difference on who gets the highest number of votes. So to me, this would be an example of a permutation because order does matter. Look at B. 6 people are on board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees can be formed from the 6 people? So again, we have a total of 6 people, and we want to choose 3 of them. And these 3 people are going to be on a committee. They're going to vote how they're going to expand the park. Yes, no, maybe, whatever it might be. When you pick these 3 people to put them on your committee, does it matter which way they sit at the table, or are their votes going to be the same? To me, their votes are going to be the same, and order doesn't matter, so this would be an example of a combination. C says, how many ways can you select 6 free DVDs from a list of 200? Now, it doesn't say your favorite, then your second favorite, then your third favorite. It just says that you have 200 DVDs, and you want to pick 6 of them. It doesn't matter how you pick them and what order you pick them in, what order you play them in. You're still going to pick those same 6. So to me, this would be another example of a combination where order does not matter. In D, it says, in a race in which there are 50 runners and no ties, in how many ways can the first 3 finishers come? First place, second place, and third place. Does order matter? Well, yeah, don't you want to be first place? Right? And so in this particular case, if you have 50 runners and you need to choose 3, but order matters, first, second, and third place, this would be an example of a permutation. So the first thing we need to do on all these problems, because eventually it's going to be all mixed up and then we're going to even add to it, we've got to be able to decide, is it a combination or a permutation? From there, we're going to solve it a little bit differently depending on which one it is. So make sure you have a good understanding of which one is which before we continue.